Hi everyone, this video is part of Macquarie University's coding tutorials, and today we'll be looking into some more recursion problems. We'll get more familiar with some patterns that arise when designing and implementing recursive solutions. We'll first look at a numeric problem called sumEvenDigits, then we'll look at a string problem called areMutuallyReverse. To start with the sumEvenDigits problem, we first need to understand what it should do. Given an integer, it should go through each digit checking to see if it's even. If the digit is even, it should be included in the sum that is returned. As each digit of a number is an integer, and we'll be summing the digits, we know that the return type will be of int. Then, to have an int to work with, we need to specify that our method will take an int parameter, which we can call number. Now we need to think about how we'll get individual digits from our number, and discard it for the next recursive call so the same digit doesn't get checked twice. For this, we can use the modulo operator on the number with the value of 10, which will give us the number's last or rightmost digit. Then to discard that digit or get a number without that digit, we can divide our number by 10. As with every recursive function or method, we need to think about the base case and recursive case. With how we plan to remove digits from our number with every recursive call, we know that our number will eventually reach 0. With the number 0, there are no digits left to check and add on to the sum, so this will be our base case. If this base case isn't true, then we'll modulo and divide our number by 10 to get the last digit and the number without the last digit. For the recursive case, if we think about our problem, we only want to add the digits to the result if it is even and ignore the digits that are odd. So we'll have one recursive case where the last digit is even and another recursive case where it is odd. If the last digit is even, then we'll return the last digit plus the recursive call. If it isn't even, then we'll just return the value we get by making the recursive call. Each of these recursive calls will take the number with the last digit removed as their parameter value, getting them one step closer to reaching our base case. One more thing to consider is that if we pass in the value of 22 and get 4, what do we think is returned if minus 22 is passed in? If we leave our design as it is, we'll be summing minus 22 mod 10, which is 8, and minus 2 mod 10, which is also 8, giving us a sum of 16. This doesn't sound right if we just want to add both 2's together, so we'll have an extra recursive case for when our number is negative. This case will just make a recursive call passing in the positive version of our number. Now that we have our design written in comments, we can begin to look at implementing our solution. First, implement the base case. If the number parameter is equal to 0, then we can return 0. Now, for our recursive cases, if the number parameter is less than 0 or is negative, then we can return a call to sumEvenDigits with minus number as the parameter value. This will make the number positive. Then we'll create a last digit variable and assign it the value number mod 10. We'll also create a remaining number variable with number divided by 10. Now we can check if last digit is an even number by doing if last digit mod 2 is equal to 0. If this is true, then we return last digit plus sumEvenDigits, passing in remaining number. If this isn't true, we can write else and return sumEvenDigits, passing in remaining number again. And that's it. Feel free to take a minute to pause the video to try implementing this yourself and call it from our main method. You can also practice tracing this with drawing the call stack with some small inputs like 1729 and 5678. To start with the areMutuallyReverse problem, we once again need to understand what it does. This problem compares two strings and checks to see if they are mutually reverse, or in other words, one string is the reverse of the other. With this problem, there are two outcomes. The strings are mutually reverse and the strings are not. We can represent these outcomes with the Boolean data type. So our return type will be Boolean. Since we'll be comparing or working with two strings, we need to have two string parameters, which we can call str1 and str2. Some things we might immediately want to think about is what if either string is null? This is a base case where we can immediately return false. Another thing to think about is if two strings are of different lengths. For two strings to be mutually reverse, they need to be of the same length, so this is also a base case where we can return false. Now, much like the sumEvenDigits problem, we'll take away individual values, or in this case characters, and do some checks on them. In this case, for two strings to be mutually reverse, we would expect the first character in one string to be the same as the last character in the other string, then the same for the second and second last character, and so on. We'll need a way to get the first and last character of each string. Then, if we find that these opposing characters are not the same, then the strings are not mutually reverse, and we can return false. We don't want to check the same characters twice, so we'll create two new strings where one has its first character removed and the other has its last character removed. This will keep the characters the method needs to check at the first and last positions of each string. Since we are continually removing characters from each string, eventually we'll get to the case where we end up with two empty strings. If our algorithm gets to this point, then we know it will have checked every opposing pair of characters, and we can say our two strings are mutually reverse, so we can return true. Finally, we can make the recursive call with the new shortened strings. And that's it for the design. Now we can look at implementing our solution. Once again, we'll fill out the comments we wrote describing our design. First, we'll check if either string is null. We'll use the OR operator of our checks, and we'll return false. Then, we need to check if the length of str1 does not equal the length of str2. In this case, we can also return false since it is impossible they'll be mutually reverse. Now, we can check if both str1 and str2 are empty by calling the string method isEmpty. Once again, if we've reached this state or we began here, then our two strings are mutually reverse, so we'll return true. Let's then create two char variables. In the first one, we'll get the first character of str1 by calling char@ and specifying the first index or position. Then, for the second char variable, we'll grab the last character of str2 by calling char@ and specifying the last index or position with str2.length -1. Now we check if the two characters are not equal. If this is true, we return false as they cannot be mutually reverse if these opposing characters are different. If we've reached this point, we know the two characters are the same, so we can call the method again, passing in str1 without its first character and str2 without its last character. To get str1 without its first character, we'll use the substring method and pass in an index of 1. Since we're only passing in one parameter, this will give us a copy of str1, starting from and including index 1, leaving out the first character at index 0. We'll store this result into a new variable called remaining1. We'll do something very similar for str2, where we'll call substring again, but pass in 0 and str2.length -1. This will give us a copy of str2 that starts at index 0 or at the beginning of the string, up until but excluding the last character of the string. We'll store this in a variable called remaining2. Finally, we can just call the recursive method, passing in the new remaining strings, and return the result. And that's it for the implementation. Again, feel free to pause and practice running the method with sample inputs in the main method. In this video, we have looked at two intermediate recursion problems. We started by designing and implementing a method called sumEvenDigits, which takes an int and returns a sum of all its even digits. We then moved on to a string-based problem, areMutuallyReverse, which determines whether two strings are the reverse of each other. We can see that recursion can be used to solve a variety of problems, and that the key to successfully implementing a recursive solution is to understand the base case of the problem, where the process terminates, and the recursive case where we move on to the next subproblem. When we have a solid understanding of these two components, we can then build a complete solution. In the next video, we'll be using the same skills and principles of recursive design that we've been learning and apply them to working with arrays and exhaustive recursion. See you there.